and should be the easiest thing we do each day. Let us start the session with a moment of silent prayer. Thank you. Predictive modeling is not about proving what will happen in the future. It's about assessing the probabilities and understanding the underlying relationships. Quoted by Nate Silver. A very pleasant evening to one and all present here. I am Varshini S. from First Sem MCom, Kristu Jayanti College, Autonomous. I now request Dr. Mohan Kumar, Faculty, Kristu Jayanti College, Autonomous, to welcome the gathering. Over to you, sir.
Continuous learning is the minimum requirement for success in any field. Brian Tracy. To my understanding, learning is the fundamental process that may help individuals, institutions, or nations survive, to shine, and to stand out. Today, the PG Department of Commerce of KGC is providing us an opportunity to learn one of the most powerful, the most influential skill of the 21st century, that is business analytics. Predictive analytics and modeling is the topic for today's discussion. So with this brief introduction, let me pass on to my assigned responsibility, that is welcoming the gathering. First of all, let me extend a warm welcome to the principal, management, and dean and other higher officials of KJC in absentia for their great support to the PG Department of Commerce, bring out such many number of programs in this department. And then let me extend our heartfelt welcome to our head of the department, whose dynamic leadership is the reason behind the success of all these kinds of activities in the department. Welcome, ma'am. And then the coordinator of this faculty development program, Dr. Cherian, he is really taking a lot of pain to make this program as a successful event. Welcome, sir. And then the professors of our department. I extend a warm welcome to all the professors of the PG Department of Commerce to this faculty development program. See, there is our person, Dr. Sreejith R. He is a professor from the Department of Business Administration of Rajagiri College of Social Sciences, Kochi, Kerala. And I must tell a few words about the resource for today's event. Our resource person, not only a professor, he is also an industrial expert in his field of expertise, that is software development. He is really assisting the industry to develop the software, various kinds of softwares. He is also a consultant in the fields like business modeling, machine learning, text analytics, .NET, and Python. To his credit, he has number of patents and copyrights from India, Canada, USA, and Australia. In a nutshell, Dr. Sreejith is not a theoretical person. He is a practical professor. So I'm sure the participants of this program will gain a lot out of his presentation today. So on behalf of the KJC and on behalf of the Department of PG Commerce of KJC, on behalf of everyone present here, I extend a warm welcome to the resource person to this August occasion. And then let me extend our warm welcome to the professors from KJC, the professors from other institutions, and the students from various institutions, the research scholars from various institutions. I extend a warm welcome to each and every one of you. Thank you so much. Welcome. Thank you.
Thank you for your warm welcome, sir. We welcome you as well. Now we have Shilpa R from First Sem MCom to introduce the resource person of the day. Over to you, Shilpa.
Thank you, Varshini. Our resource person for the day is Dr. Sreejith R, Assistant Professor, Rajagiri College of Social Science, Autonomous, Kochi. Sir did his PhD in Computer Science and Engineering from Reva University, Bengaluru, and MTech degree in information technology from Anna University. Sir possessed over 12 years of teaching experience. Sir is actively involved with Rajagiri software development team. It showcases Sir's expertise in data analytics, business modeling, machine learning, text analytics, and web application development and security. Beyond teaching, Sir is a consultant and trainer in Python, Django framework, and .NET framework, and other emerging technologies. Additionally, Sir's extensive research contribution have been published in esteemed top tiers journals in domains of information security and business analytics. Sir also holds several patents and copyrights, primarily in IoT and AI related areas, further showcasing his innovative contribution to the industry. We are glad to have you here, sir. Over to you, sir.
A warm good evening to everyone. I believe I'm audible. Yes, sir. Thank you. And thank you, Mohan sir and Shilpa, for your warm welcome and introduction. I'd like to start this session by re-quoting the statement made by Professor Geeta on the day one. Analytics can be approached from different levels, such as descriptive, diagnostic, then predictive and prescriptive. So with that context, we can divide our analytical exploration into two forms. Maybe from the simplest form, we'll try to answer what has happened as well as why it happened. So that comes with descriptive and diagnostic one. In the advanced form, we try to answer the questions, what will happen as well as what should we do if this may or this may not happen. That talks about the predictive and prescriptive one. And that can be achieved using various mathematical, statistical, or neural network models to get the patterns and trends so that we can predict as well as we can optimize what we have to do. As today's topic is related to predictive analytics and modeling, it's very needed to give a short intro about the concepts related to machine learning. And in this context, so generally machine learning will have three different approaches. One can be supervised, unsupervised, and the third one is actually reinforced machine learning algorithms, where it's beyond our scope. We'll just stick with supervised and unsupervised one. So based on the type of data what we have, we can choose between supervised and unsupervised algorithms. So when we have a label data with us, or we have the target variable, or I can say we have a set of variable and the result happened because of that variable. That's what we call as target variable or labeled variable. We call it as labeled data. If we have such kind of data with us, labeled data with us, and based on what kind of that dependent variable is all about, then we can choose between classification and regression. In the sense, if our variable, what we want to predict, is actually categorical, then we call it as classification data. If that dependent variable is actually continuous numerical value, then we call it as regression. And when it comes to unsupervised, we don't have any result or the class with, label with us. So that's what we call as unlabeled data. So from that data, what maximum what we can do, we can divide that observation into different clusters or group based on different combinations of similarity, by which I can go and understand more about why those data points group together, so that I can learn more about that concept, just like it's also part of descriptive analytics, but in a more analytical way. So I can have a personalized approach for each clusters if needed. Then what else I can do? I can do something related to association mining. For example, in our classes, if we try to consolidate the attendance sheet, everyday's attendance sheet who are present and absent, then what I can understand after the 6 months of data, I can see which student is influencing another student to be in the class. If there any influence of a person, that relationship I can association I can extract out of it. That's what we call as generally association mining. And the third one is actually dimensionality reduction, where I'll try to reduce the number of variables for different purposes, maybe for optimized result, or maybe for visualization purpose, or to reduce the computational cost. So anyway, that's what we can do with supervised and unsupervised learning. And as is a predictive analytics part, either we should go with classification and regression. I believe regression is more common uh, and popular. So I'll just give an idea of classification algorithm with rule-based mining using data, decision tree as well as random forest. So that's my plan for the session. Classification, I can approach this problem using different methods. For example, rule based method, that's what decision tree does, or I can go with regression based using logistic regression, or I can go with the hyperplane division method, SVM, or probability based approach, naive base, and not many things, or neighborhood relationship using the nearest neighbor method, KN method. So I can use a lot of methods based on the data and relationship between those data. So for the today's example, we'll go with decision tree as the initial part, followed by random forest if time permits. So that's my plan. Right. Now, what's all about decision tree? So we'll have a short small outlook how it looks like. In the picture you can see a decision tree rule that's actually a sample decision tree model to predict whether a candidate or a applicant will get a loan approval or not. So if so this model was trained and constructed in a way like when a new applicant comes, I will ask whether are you student or not. Based on that answer, then I will traverse through the tree and I will reach whether that loan will be approved or not. So this tree construction is actually called as decision tree model, where these are actually nodes and rules. So which attribute should be chosen, what is the condition, and how should I traverse. So this tree construction is actually called as the decision tree. So once we construct this model, then once a new observation comes in, I'll just follow with the decision nodes at each level, and when I traverse through that rule, I'll be able to reach the answer, or I'll be able to predict it. So basically, major point happens with how do you choose these variables. So there are different variable in the data set where age, income, CR, student, and lot many. So how do you choose which variable and what is the criteria? So that concept is actually called as decision node criteria or splitting criteria. So that can be identified by two different techniques. One is information gain, second one is Gini index. So these are the two different methods used to identify which node can be the decision node at different levels. So based on this, we have three implementations of decision tree: ID3, C4.5, CART. CART in the sense classification and regression tree method. So CART implementation actually uses Gini index by default. Again, we can change from the parameter, but by default, Gini index is the method used for decision node criteria selection for CART method, which is the one which we are going to learn it. I'm not gonna very detail into the formula, but generally basic understanding. Information gain and Gini index was developed from different perspectives for different reasons, but both are used for decision node identification or splitting criteria identification. One works with the concept of impurity measure. From that impurity, highest impurity, with the highest information gain, which variable provides highest information gain, that will be identified and chosen. And the second one, Gini index, worked on the base of probability of misclassification, and that's actually a concept of probability itself. So both will have a different approaches to identify which variable can be chosen for at each decision rule criteria. But comparing, Gini index was most popular based mainly not for the result but for the computational cost. Hope you can see in information gain there is a log operation happening. When it comes to Gini index, we don't have any log operation. So that log operation will increase the computational cost, and majorly because of that reason, many algorithm or implemented algorithm actually uses Gini index for calculation of decision split tree. Then for today's session, for the practical session, I have chosen a use case where, as most of us are academicians, will be uh, understood with the student related examples. So for this example, I've chosen a salary range prediction where assume we have maybe 3 to 4 years of alumni data with us, and that's all about their age, gender, and their schools and undergraduate marks, along with various their attributes like sports, extracurricular, interpersonal communication, whether they had backlogs or not. So there are different parameters related to each student, and when they pass out, what salary they have received, the salary range in the sense high, low, or medium salary. It's not a numerical value. That's again a categorical value. So clearly mentioned that's a categorical value, like whether the student got a high salary or medium salary or low salary. So the business problems understanding, it's all about we have labeled the data with us, in the sense alumni data, where we have each student parameter related to their personal details, as well as what is the skill they have with respect to non-academics and their academic related details. And we can see the gender is actually categorical, male, female, or others can be. Then communication skill, whether they have a good communication skill or not. Then backlogs, again, whether they have backlog or yes or no. And salary scale, based on all those property, what kind of salary scale the student have received, maybe high, low, or medium. So in general, machine learning process start with business understanding. That's what I was trying to convey here. What is the business statement we clearly mentioned? And once we know that, we'll try to understand about the data. That's what we are talking about, the data variable now. So once we understand about the data, then sometimes there will be a need for data pre-processing. That pre-processing can be related to data cleaning, or data transformation, or data type conversion. For example, the number was stored as a string, then I need to convert back into numerical, or such instance may be needed. Or maybe like there will be a missing value in some particular columns. I may need to just remove or impute that value with appropriate value. So anyway, that all things falls into data pre-processing. Once we know that the data is clear and ready for modeling, we will go with understanding what are the relationship between the dependent and the independent variable. And once we know that, we will choose appropriate model methodology for modeling. Once we complete the model, there are various evaluation criteria associated with each type of models adopted, and based on that we will evaluate the model. If we found okay and ready to go, then we will deploy it as a product. Or if we fail with some reason, then again we'll go back to trying to understand the business understanding or business problem statement. Then we'll again try to understand the data once again, and the cycle keep on going until we are completing the process and deploying it. So we are trying to understand, or we are trying to go with a hands-on session from data reading to model evaluation using R programming. So this is all about our today's session. This is our data Hope you have received the data student salary. And let us have a data understanding at the beginning, where we have a first column. The first column is not actually the data, that's actually the name of each row. So the row name is 1, 2, 3. So this is not data we need to be understand. That's again just row names. And we have gender is actually categorical. Then we have communication skill, good, average, and low. That's again categorical. Backlogs, the student have a backlog or not, yes or no. Then salary, which is the one which we want to predict. So we assume salary, the student that salary received or got or acquired is actually dependent on all other variables, associated variables. So that's why this is called as label or dependent variable. The salary class is dependent on other independent variables. So we try to understand about the data. We don't have any missing value at the first look, and we'll try to create a model for predicting salary class for our current batch student. So that's the basic idea. So we'll construct a classification model to predict salary based on the other parameter, so that for the current batch of student at the earlier stage, I can predict what type of salary they will get at the current stage of going. Either I can strengthen that, or I can make them to uphill and get a better salary range. So that's the basic idea behind this modeling part. Shall we start modeling concepts? Right. You can log into the POSIT cloud for RStudio cloud version. Either you can use your R and RStudio in your laptop, or you can log into your POSIT cloud for RStudio online. So in this statement, you can go to File, New File, R script. At first stage, I have chosen File, New File, and R script. Then go to the right bottom panel where files plot, those menus are available. Let us upload our data file here. Upload, click upload, choose the file, student salary, upload. Files, upload, choose the files student underscore salary.csv, upload. Now let us read the data and save it into a variable called as data itself. Data, that less than symbol and a hyphen. It's instead of equal to, we will be using assign simple. In our programming is R is actually a statistical, mainly statistical kind of language. So our programming is an interpreted as well as statistical language. So data, I'm trying to read the data using read.csv. So this is the function we use to read the data. And once we read the data, then we will be saving back the data to a variable called as data, in which there are two options. Either I need to provide the location like c.colon something. As we don't want to do that, I'll go with file.choose, where it will help us to choose the file, the file which we uploaded. We can choose that file using a GUI method. Then as we observed, we have the first column is actually row names, not actually the data. So what we want to say, row names equal to 1. So this will read the file by saying the first column value is actually row names. Control enter to execute the line. Control enter. You can select the data student salary.csv. Open. I'll repeat the steps once again. Once you open or log into Posit Cloud, File, New File, R script. Then you can upload that data file. In the file upload button, you can upload it. Once you have done it, let us read that CSV file using read.csv function with the file location. And as I identified, the first column is not actually the data, that's the name of each rows. So row.names equal to 1. If I identified that names in the fifth column, then I would have renamed as row.names equal to 5. Now let us view that data using view function, where V is actually uppercase, V is capital letter, VIEW with data. I can see that data which we uploaded in a grid format. This V is uppercase one, VIEW. Right. Now we need some packages for modeling. Just like our C and C++ library, we need some set of libraries to do the modeling part. Let us install one by one. Install.packages. The first one is rpart. rpart. Control enter. It's got downloaded. Install.packages in double quotes. rpart.plot. So first one is for decision tree model. Second one is to visualize the decision tree. Control enter. Then third one for evaluation purpose, caret, CARET. Then we need something called as random forest. Random forest where F is uppercase 1 for random forest model creation. So if time permits, we will have a look on a decision tree model, the same problem solving using random forest, which is again an ensembler based method. I'll try to speak at that time. So when we install all those packages, let us import all those packages to our environment using library function, library rpart, control enter, library then caret, library random forest. Actually, we can install the same thing from this packages menu. Packages install, we can do the same thing from here. I can search for random forest and I can install it. But I will not recommend this because maybe in the later day, we may forget which package we installed for this analysis. So better either if you are so structured and you will used to write which are the packages, then you can go with this method, or strongly recommend to install using the code so that we will have which are the packages used for reference later. So once we have the data packages with us, let us work on data pre-processing. For that, let us try to understand the structure of the data using str function. So str of data. So from str of data, structure of the data, we can see age is actually integer, gender is actually character, then we have communication skill as character, backlogs as character, salary as character. But these are not character data. These are actually categorical data. I just want to convert these string data into categorical. It's not name kind of thing. This is actually choice, male or female, higher choice. So these are category. So in R programming, categories are created using called as factors. For example, or how to convert it using as dot factor. So factor is the method used in R programming to convert a normal vector to categorical. So as dot factor, I just want to convert this gender into factor or categorical. So as dot factor data dollar, I'll be using dollar symbol to choose which column I want to be selection, gender. So I'm converting this gender column and saving back to the same column, data dollar gender. Control enter. Similarly, let us do for all other instances. We have something like communication skill, fine. Data dollar communication skill, convert it as dot factor, fine. Then we have backlogs. So data dollar backlogs, convert it as dot factor, fine. Now we have salary. So data dollar salary, now let us check the structure of the data once again. We are able to identify gender was converted into factor. Earlier it was character, now it was converted into factor with two levels in the sense two category, with female as well as male. So string was converted into numerical associated values with each category. So female and male are two levels here. Then communication skill also converted into factor with 3 levels, and backlog with 2 levels, yes or no, and salary with 3 level, high, low, and medium. So this is all about data pre-processing for this particular data. As there is no missing value, we don't want to touch that part. So our data pre-processing part is done for the time being now. Now let us check the statistical summary of the data using summary function. So summary of data. So from the summary function, you can observe the spread of data age with the minimum 21 to maximum 32, median value was 25. And if how is the spread of data, we can understand. And gender, we have 56 alumni with female and 64 with male. And finally, what we are very interested is at the target variable salary class, where with observation with the high salary 52, low salary with 29, and median with 39. So there is almost equal balance with all the three classes, in the sense number of observation with respect to each target variable, each category is actually almost equal. So there is no need of any data imbalance problem. So if it is a very huge difference, for example 1000 for high and only 100 for low, then there is a chance of a class imbalance problem, and we need to address it. So at this part, we don't have any class imbalance problem. We can continue with modeling purpose. Right. Now let us divide the data into training and testing. As we are dealing with a label data, we are dealing with supervised machine learning algorithm, where we need to divide our data into training and testing purposes. So training and testing, how to divide it? We have some, there are different methods to do it. We will use one function called as create data partition. So create data partition from caret package. We'll use that one to divide our data into two for training and testing purpose. So which data we need to use for data salary class. Then I need to say what probability we should, what partition we need to make. So for 70% for training purpose, rest 30 for training purpose. If that's the case, then 0.7 for training purpose. Then I don't want this as a list. So that's a part of this function. Either that data can be returned as a list or as a data frame. So as we want it as a data frame, I'm just putting that list equal to false. I don't want it as a list of value. So now save back that partition index. So this will give you some row numbers. So that row numbers can be saved into something called as index. So create data partition function will return you random row numbers from number of rows in this particular column with 70%. So that row numbers will be randomly generated and saved in index. As there is a randomness in here, it is better to set a seed value, set.seed 123. There is nothing related to analytics, set.seed. So this is all about keeping the constant randomness. For example, if I said 123, if you all set as 123, then all the result will be common and comparable. If we are not using the same number, then your result and my result may vary because randomness also varies. So basically, if you want to compare with my result, set that set.seed value as 123 itself. Control, select both the line, control, enter. Then let us split the data into train and test. Train from data, which are the row values in index, comma, all the columns. So from the data, the row numbers are in index, that row numbers, comma, all the column values should be taken to train. Then for test purpose, from the data which are not in this row, minus index, comma, all the columns. So this minus indicates which are the rows not available in this particular 70%. That will be taken, the rest 30 number of rows will be taken for testing purpose. So if you want to see how many rows are there in each data, n row of train. There are 86 rows for training purpose. Then we have 34 rows for testing purpose. We have divided our data into train and test purpose with the 70-30 ratio. Repeating the process for a minute so that if somebody wants to complete, can complete. Reading the data with file selection. As our data have first column as row names, I'm setting row dot names equal to 1. Then if I want to view the data in a grid view, then I can use the function view with v uppercase. Then there are few packages needed for modeling. For R part is for decision tree model, rpart.plot for decision tree view, caret for data splitting as well as evaluation purposes, random forest for random forest model. Once you install all those 4, then we can import that packages to our environment using library function. So once that is over, then we can check the structure of the data, where after checking the structure, we came to know all the character data is actually categorical. So how to create a categorical, how to convert or how to say the system, this is categorical variable. There is something called as factors in our programming. So as dot factors will convert the columns into factor and save back to the actual original column itself. Once it is converted, then we can say factors are categorical with different levels. Levels are the category. And we try to understand the statistical summary of the data, and we found there is no data imbalance with respect to the target variable. So once we identify all those things, then we can divide our data into testing and training, where 70 percentage partition of 70 percentage for training and the rest 30 percentage for testing purpose. So for that purpose, there are different way to do it. For the easy case, we are going with create data partition, where I'm talking about how many number of rows are there from the data dot salary, from which I need to say how many is needed for training purpose. And I don't want the data as a list. I want is as a vector itself. So I'm just saying list equal to false, and save that row numbers, 70 percentage roll number randomly generated to index. So set.seed is actually nothing related to statistics. That's all about the randomness start of seed of randomness. So when you set value, we all set the same number, then we will all get the same random values chosen and our result can be comparable. So that's the reason why we said 1, 2, 3, or anything can be, or everyone should be setting the same thing. Once that index row numbers are generated, we can say from data with these row numbers take to train. Other than that, minus index can be taken for testing purpose. Let us create a decision tree model to predict salary class. It's as simple as that. Use the function rpath. So this function will help you to create the decision tree model, where you can see formula, data, and weight. From the pop-up, you can see these are the mandatory input which you have to weight. So here, rpath, I want to predict salary class. So that let me to minimize the error. Let me get the column names of the data directly, so that I can copy paste and get it, so that I can avoid some silly mistakes. So I want to predict salary class, a tilde symbol, not hyphen, the tilde symbol, which is just before the one numerical one key. So that tilde symbol, and I will be adding the variable which I want to use as dependent variable next. So age plus gender plus, I can add as number as variable I want as a dependent variable. But better, let the system choose which is the appropriate variable using dot. So what this dot means, salary class will be our dependent variable, tilde symbol, right hand side, all the other variables other than salary class should be taken as an independent variable. And it will come from data. Our data is actually trained. We'll use the trained data to train the model. And as our part is actually a cart model, cart in the sense classification and regression tree. The same can be used for regression too. I'll need to mention method, which method I need to use. I need to go with class. And let us save that particular model into something like stu underscore model. You can name something. Model is created. If we want to see what is the rule created out of it, then rpart dot rules stu model. So this is the rule which decision tree rule generated to predict what is the salary of class. So in this model, you can see undergraduate mark was selected as one decision node. Then secondary mark was selected, and that's it. Based on these two variables, they have completed the modeling. This is the best model which they can be made from decision tree. So if you want to see which are the variables in importance, just like in our regression model, we try to understand the relationship using correlation. Similarly, we will have something like Gini decreasing Gini method using a function called as variable importance function, variable importance of stu underscore model. So this will give you an idea which are the variable have higher importance and lower importance. So in this from this you can clearly say gender have least important in predicting whether a student will get a higher salary or current PG score is also not that much important, but which is having the highest importance, you can see the secondary mark. Secondary mark is the very highest importance for prediction, followed by interpersonal skills, followed by many other sections, undergraduate mark and much more. But even though there are higher significance, when it comes to model, some variable will be ignored to get a better accuracy model. So this will help you to understand which are the variable having significant effect on the salary. Now what we can do, we need to predict the test data. We have divided our data into test and train. We will predict the test data using our model. So predict is a function used to predict a set of data. Predict using STU model, using this model, predict test data. So test, what type of method it was? It's a classification. So class, predict it and save the result in something called as predicted salary. So our model have predicted the first value in our test data as medium, second one as high, and so much. Now what we have to compare is like already we have the result of this train data, test data. We need to compare that test data result along with the predicted value, so that I can understand how good the model is performing and how good I can use for deployment. So that's the second way we are going to do it. Right. To do that, let us create a confusion matrix. So confusion matrix, the function is readily available in Caret package. So confusion matrix is the one used for all classification problems, where I'll try to compare the predicted value, predicted class with the actual class of my test data, so that I can see how good it was predicted. So I want to compare predicted salary with my test dollar salary. I'm comparing my predicted one with actual data or actual instance, and I want to see all the result associated. So mode equal to everything, or else I won't get the F1 score and all. So I'm just setting mode equal to everything. Control enter. Right. Now you can see the overall accuracy of the model is 85%, but we can't trust this accuracy as it will talk only about the positive occurrence. We need to check other three parameters like precision, recall, and F1 score. So here precision of prediction on high class is actually 87%, and precision on predicting low class is 1, and medium is actually 0.75. So what this says, when the system says he will get low salary, it's 100% right. But you can see the recall, its system will sometimes misses many low class salary predicting medium or high class. When it says low salary, it will be 100% true, but system will only capture maximum 75 percentage of low salary from our data. And the precision of high salary students, the precision is almost 87%, and recall value is also high, so 93%, and overall F1 score is 90. So generally F1 score is used to compare the model performance between different models. We don't go with accuracy, as this will not give a better insight. So F1 score can be used to compare different model solutions to see which one is performing better. So when, as a whole, when I look at it, the model is good for predicting high salary students as well as low salary students, but it's not that great, but still it's acceptable 0.78% accuracy for the medium salary students. So this is what we can interpret or evaluate from this model. Now quickly let us compare, or we'll create a random forest model, or if you want to visualize this decision tree, how it looks like, I can use something like rpar.plot function and stu underscore model type equal to 1 for different types of plots are there. This is the best fit one. So type equal to 1 with the font size CZ equal to 0.8. You can, at the right side, you can see the decision tree. So this is the model. When a new student comes, it directly checks with the question undergraduate mark, whether that undergraduate mark was greater than or equal to 77. If yes, then the student will get high salary. Then if no, then the question will be secondary to secondary mark, whether it is greater than 74 or not. Then based on that, if yes, then again. So based on that, finally through the traversing, I'll be able to predict what type of salary the student will get. Random forest model for the same problem. So nothing different. We will use random forest function, the same formula where I want to predict salary and train, the same thing, no much difference. I want to predict the salary using all the variable, using the train data. Then one more parameter is required, something like number of trees required. So random forest is actually ensembler method, in the sense collection of different tree. So this in the previous example, we have created only one decision tree for prediction. So in random forest, we will create multiple number of tree, and a consolidated result was, or ensembled result was taken as a final result, just like more number of judges kept for some event. So collective opinion of the judges was taken as the final result. So how many trees are required? I can go with 50, 100 based on different iteration. I can fix number of trees. So for this example, I'm just creating 50 decision tree as the collective decision makers. And let me save this model to stu model 2. Let us create a second model for the same thing. Fine. Now, as we don't have we don't have a single tree, we have 50 different trees, such trees, decision tree. Let us get one tree rule, get tree from stu model 2 k equal to 2. Second tree, we will check the second tree rule from 1 to 50. We are just randomly selecting k equal to 2 with the label variable. I just want to see the label name 2. That's why I'm putting as label variable equal to 2, GRUE. So in decision tree, when number of variables are increased, you can see it have used many variables other than undergraduate and postgraduate. You can see sports score was used, communication skill was used, age was used, higher secondary. I'm able to construct a better model out of it by utilizing all the variables. And the same thing what I can do, let us check the variable significance using VAR importance of STU model 2. Now you can see, based on random forest model, I'm able to identify almost for all the variables there are having some significance other than gender. Gender is still having zero significance for predicting whether a student will get a high or low salary. But other than that, you can see still undergraduate mark is the highest important variable followed by other variable. Now let us evaluate the model using predict using STU model 2, second model on my test data type equal to class, as it's a classification model, and save the same back to predict STU 2, predicted salary 2. Let us create a confusion matrix for or between predicted second predicted salary as well as my test data dollar salary scale, and I want to check all the values, so mode equal to everything. So now you can see the F1 score getting stable, and the accuracy of the model can be increased or decreased by changing the tree number into different numbers by trying random try, as well as there are different other methods. But I can increase or decrease based on setting the variable value. So set dot seed to make everyone's prediction same. Why I put a set dot seed value here? There is a random tree generation happening here. So for that randomness, set dot seed is required. So that's the reason why I'm adding a set dot seed for this random forest model. So in this way, we can compare the two different models, and I can select a better model out of it. Precision talks about model's ability from the prediction perspective. So when I say the student will get high salary, how accurate it was? It was a precision. Recall talks something like how many high salary students was there, and out of which how many are uh, predicted or locked using our model. So that's actual perspective, you called as recall. And F1 score is actually calculated just proxy of accuracy. It is calculated from precision and recall using the combination of formula 2 into precision and recall by precision plus recall. So this will be a better metrics to compare models solutions. And that's it for my today's session. And I know I just went a bit fast, as I believe the recorded session will be given to the participants, and I'm trying to give maximum in 1 hour. Sorry if I'm too fast and you're not able to complete on time. And floor is open for any discussion or something if needed. It's open for discussions.
Thank you, sir. It was really an informative session. Delegates, now the floor is open for Q&A.
Participants, you can post your questions in the chat box.
Dear participants and delegates, the feedback link will be shared in the chat box. Kindly ensure that you fill the same. Gratitude makes sense of our past, brings peace for today, and creates a vision for tomorrow. I now take this opportunity to extend our gratitude to the resource person, Dr. Sreejith R, Faculty, Rajagiri College of Social Sciences, Autonomous, Kochi, for giving us a fruitful knowledge on the topic predictive analysis and modeling. Thank you, sir. A bouquet of thanks to Dr. Madhu Dhruva Kumar, Head, Department of Commerce, PG, for her constant motivation to scale greater heights. Thank you, ma'am. I would like to thank Dr. Cherian Thomas, FDP Coordinator, for the support. Thank you, sir. I would also like to thank all the participants and delegates for being such an amazing audience and making this event a success. Thank you, everyone. It's my duty to thank our department faculty members, Dr. T.K. Murugeshan, Dr. Pushpa A, Dr. Vidya S, Dr. Mohan Kumar. Their assistance for the conduct of this event is appreciable. Thank you, dear teachers. My deep sense of gratitude to the students of first and third SEM MCOM and MCOM FA for being a part of this program. Thank you, dear friends. I also convey my gratitude to the non-teaching staff, especially the tech team, for their efficient online support throughout this session. Thank you. Dear participants, tomorrow's session will start at 3:30 p.m. Kindly ensure that you join the same link. Thank you. I remain.
Sir, thank you so much.